Hello students, welcome back to the second video of this playlist. So in this video we will be solving the second question from January 2024 Statistics 1 paper. So let's see what's the question number 2 is about. So basically the concepts behind question number 2, it's a combination from different chapters of your statistics book. Mostly the concepts are from correlation and regression that has been discussed in chapter number 5 of your statistics textbook. Like you need to find out the PMCC, you need to deal with summary statistics, and also there are concepts from coding that has been discussed in chapter number 2, measures of spread and location, like coding formula, like dealing with coding, like dealing with coded data. So now in order to be able to understand this solution of this question, definitely you should have know the concepts behind like this question that is discussed in chapter 2, that is measures of spread and location, and chapter number 5, which is correlation and regression. Okay, so let's get started with question number 2. Okay, so here the question says the average minimum monthly temperature x degree Fahrenheit and the average maximum monthly temperature y. The average minimum monthly temperature, it is x, and the average maximum monthly temperature, this is what, y. Okay, in Kolkata were recorded for 12 months. Okay, it has been recorded for 12 months. Okay, so some of the summary statistics are given below. The summary statistics are given below. Sum of x is given 862. Sum of x squared, it is 62,802. Like statistics of yy, that is S of yy, this is 413.67. S of xy, which is 512.67, and number of data is what, 12, because they are considering 12 months here. So first question, part A, it asks calculate the mean of the 12 values of the average minimum monthly temperature. Minimum monthly temperature. So we need to find out the mean for the what, minimum temperature. So minimum temperature is what, x, right? Okay, so we need to find out the x bar. Okay, for part A we need to find out the x bar. So x bar would be what, sum of x over what, n. So sum of x is given there, right? Sum of x is what? Sum of x is 862. So you will get 862 over what, 12. So what would be the value? 862 over 12 gives you 71.8, or if it is in exact form, you will get 431 over what, 6. Okay, this is the average minimum monthly temperature. So you can say how much is this in decimal? 71.8. Since they gave to one decimal place, 71.8 degree what, Fahrenheit. This is the average what, minimum monthly temperature. Done. Next, part 2. Show that the standard deviation of the 12 values of the average minimum temperature, minimum monthly temperature is 8.57 degree Fahrenheit to what, 3 significant figures. Okay, so we need to find out the standard deviation. So what's the formula for standard deviation? Standard deviation, this is sigma, isn't it? Sigma is equals to what, square root of the variance. So variance is sum of what, x squared over n minus the mean squared. Fine. So sum of x squared over n. Do we know the sum of x squared? Let's check the summary. yeah, it's given 62,802. So 62,802 over n is what, 12, then whole square root what, minus the mean square. Mean is what, 431 over 6 whole squared. Done. Now find out the value. We will be done with part 2 then. So 62,802 over 12 minus what, 431 over 6 whole squared. Okay, so square root of answer, you will get 8.57. That's what they asked for. Yes, 8.57 degree Fahrenheit. Okay, so it's basically 8.57 15 something, it keeps going. Okay, so it can be written to what, 8.57 degree Fahrenheit to how many decimal place? To 3 significant figure, they said. Okay, according to the question, it is 3 significant figure. Done. Next, for part B, they are asking to calculate the PMCC, product moment correlation coefficient, between X and Y. We need to find out the PMCC between what, X and Y. So what's the formula for finding PMCC? It's given in the formula booklet. You can use it, like if I show you from the formula booklet, it's given in the formula booklet. So let's see the formula for what, PMCC, the product moment correlation coefficient. You can find it in the S1 statistics part, S1 part. So from statistics S1 part, you can in the formula booklet go to statistics S1 part, then you can find this formula for R. Okay, this is the formula for the product moment correlation coefficient, PMCC. Okay, so this is S of xy over square root of S of xx times S of yy. So we have all of these values in this summary statistics. S of xy is given, S of yy we have. Just we need to find out S of xx. So let's find out the value for S of xx at first. For finding PMCC, we need at first what? The value for S of what? xx. So S of xx equals to what? S of xx equals to, this is for part B, this is sum of x squared minus sum of x whole squared over n. This is the formula for S of xx. It is also given in the formula booklet. Okay, you can find it out from S1 formula booklet. Look here, it's given. Okay, so it's not required to be memorized, but if you can memorize, definitely it's better, because it will save your time. So sum of x squared is how much there? It is 62,802 minus sum of x is how much there? 862 whole squared over n. N is what? 12. So what would be the value? 62,802 minus what? 868 squared over 12. So you will get 50 over 3. 50 over 3, it's the value for S of xx. Okay, now we need the value for PMCC, right? So R, this is what? S of xy over what? Square root of S of xx times S of y. So what would be the value? The value for S of xy it's 512.67, 512.67, and the value for s of x we already have here, which is 50/3, and the value for s of y, it is 413.67. so 413.67. okay, so now we need to find out the value. Use your calculator to calculate the values here. Okay, so 50/3 times what? 50/3 times 413.67, square root of answer. So 5, that would give you what? That would give you 4 point something. Oh wait, so it's not 50/3 over there, it should be, it's 62 squared over 12. So 62,802 minus answer, this is basically 881.67. so this is 2645 over what? 3. so just put 2645 over 3 there. So that should be 2645. Now it will be fine. So 2645 times 413.67, and then square root of whole answer. So you'll get 512.67 over answer. This is 0.8489. okay, 0.8489. so that means the value for R to 3 significant figures, you can say 0.849. Done. This is the value for PMCC. okay, next is part D. Part C. okay, for part C they are asking for comparative purposes with a UK city. It was necessary to convert the temperatures from degrees Fahrenheit to degrees Celsius. So to convert from Fahrenheit to degrees Celsius, they used this formula. This is basically, you can say, a coding formula. Fine. Where F is the temperature in degree Fahrenheit and C is the temperature in what? Degree Celsius. Okay. Use this formula and values from part A to calculate in degree Celsius the mean. We need to calculate the mean in degree Celsius and the standard deviation of the 12 values of the average minimum monthly temperature in Kolkata. Okay, so give your answers to 3 significant figures, 3 SF. Okay, so we need to find out the mean, that is the coded mean, and the standard deviation. So let's do that. So at first, for mean we can directly use the formula, right? For mean we can use the formula directly, that is we need to find out the mean temperature in degree Celsius, right? Yes. So C bar equals to 5/9 times what? F bar minus 32. So we already know the value for F bar. So C bar would be what? 5/9 times F bar. What's the value of F bar? The value of F bar we found in part A1, which is 431/6, right? So this is 431/6 minus what? 32. Okay, so what would be the value? 431/6 minus 32 times 5/9, so which will give you 1195/54. So 1195 what? 54. So we got the value for the mean temperature in degree Celsius. Fine, which is basically how much? 22.1. okay, 1 decimal place is 2 decimal place, so they gave the values to 2 decimal place, so consider 2 decimal place, which is 22.13, okay, degree Celsius. Done. We got the mean. Now we need to find out what? We need to find out the value for standard deviation. So the concept from coding. For coding, we know that if you code a data for addition or subtraction, the what? The standard deviation doesn't change. But for multiplication, the standard deviation gets changed by the what? Multiple amount of value. Okay, so that means here the multiple, the 32 has been subtracted from the what? F, so it will not affect the standard deviation of the what? Fahrenheit, of the Fahrenheit, yeah. But since the form in this formula 5/9 is the multiple, 5/9 will be multiplied with the F, okay, so that means what? The standard deviation of Celsius scale will get changed by multiple of 5/9. So in that case, we need to find out at first the standard deviation for Fahrenheit. So what's the standard deviation for Fahrenheit? We already found this in part 2 of A, right? Part 2 of A, which was 8.57. Okay, so that was 8.5715. Okay, so that means what? Standard deviation for Celsius scale. So standard deviation for the Celsius scale, that would be what? 5/9 times what? 8.57, something keeps going, so 5/9 times 8.57 would be what? It would be 5/9 times, okay, this is basically 4.76 something, okay, 4.7611, it keeps going, 4.7611, it keeps going, okay, that much degree Celsius, so it can be rounded to 2 decimal place, which is 4.76 degree Celsius. That's it. Done. Next is which part? Part D. Okay, in part D, what they have asked, okay, they said to 3 significant figures. Okay, for 3 significant figures, the value for mean should be what? Only one. Okay, 22.1 degree. Okay, 22.1 degree Celsius. Okay, let's move to part D. Given that U is the equivalent temperature in what? Degree Celsius of X, and V is the equivalent temperature in degree Celsius of what? Y. Okay, now state giving a reason, the PMCC between U and V. What would be the value for PMCC between U and V? Okay, U and V are basically equivalent temperatures for X and Y. Okay, now we need to mention what would happen to the PMCC value between U and V. Will it remain same, or will it get changed? Definitely it will remain same, because coding doesn't affect the value for product movement correlation coefficient. Clear? Okay, so for part D, they asked for the state giving a reason, the value, right? The value would be what we found earlier. It was in part B, we got this as 0.849. Okay, for part D it would be what? Remain same. Remain same, that is what? r equals to 0.849, right? That was 849, yeah, 849, since coding does not affect what? Affect the value of what? PMCC. Okay, that's the reason why the value for PMCC will remain the same. So this is all about question number 2, and that's the end of question number 2 of January 2024 Statistics 1 paper. That's it.